Amazon Virtual Private Cloud, VPC Overview. Amazon Virtual Private Cloud. Amazon VPC is like your own private cloud within the AWS cloud. It lets you provision a logically isolated section of the AWS cloud, where you can launch AWS resources, in a virtual network that you define. This is a virtual network dedicated to your AWS account. Alternatively, your AWS account comes with a pre-configured default VPC in each region. You can launch your resources into the default VPC right away. Amazon VPC also provides you with complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. To get started with creating a VPC, you must assign it with a range of private IP addresses. Amazon VPC supports IPv4 and IPv6. Your resources can communicate over IPv4 or IPv6 or both. By default, it uses the IPv4 addressing protocol. You can also bring your own IP prefixes. A VPC spans all of the availability zones in the region. After creating a VPC, you can add one or more subnets in each availability zone. A subnet is a partition of a VPC's IP address range. For example, your VPC has a total of 1024 IP addresses, and you configure 4 subnets, each has 251 IP addresses. Each subnet must reside entirely within one availability zone. You can launch instances into subnets in multiple availability zones, to improve fault tolerance, and hence, building highly available applications. Creating multiple VPCs is supported. In one AWS account, you can create up to 5 VPCs per region by default. If more is required, this limit can be increased through AWS support. Now, let's talk about the key benefits of Amazon VPC. First, it is simple. Using the AWS Management Console, VPC can be quickly and easily created. You spend less time setting up and managing, so you can concentrate on building the applications that run in your VPCs. Customizable. You can easily customize the network configuration of your Amazon VPC. For example, you can create a public-facing subnet for your web servers that have access to the internet. You can also place your back-end systems, such as databases or application servers, in a private-facing subnet with no internet access. When you configure VPC to connect to your corporate network, it can serve as an extension of your own data center. In addition, VPC can also be connected to other VPCs. Secure. Amazon VPC provides multiple layer of advanced security features, such as network access control lists, NOCLs, and security groups, to enable inbound and outbound filtering, at the subnet and instance level. In addition, you can store data in Amazon S3, and restrict access, so that it's only accessible from instances inside your VPC.
AWS Systems Manager Overview. AWS Systems Manager is a collection of features that help you manage your IT infrastructure, running in the AWS cloud or on-premise data centers. AWS Systems Manager simplifies the management of your applications and IT inventory. AWS Systems Manager, thereby, helps reduce the time it takes to detect and resolve operational problems. In summary, AWS Systems Manager helps you manage your AWS resources securely and at scale. AWS Systems Manager features. AWS Systems Manager is the operations hub for your AWS applications and IT resources. AWS Systems Manager functionality is broken up into 4 core feature groups that help you implement operations management best practices. Operations Management. AWS Systems Manager Ops Center provides a central location where operations engineers and IT professionals can view, investigate, and resolve operational issues affecting AWS resources. Change Management. Use Systems Manager documents to automate common and repetitive maintenance and deployment tasks. You can use automation, To reset passwords on servers, apply OS patches, and remediate compliance issues. Application management. With Systems Manager Application Manager, you can define your application components based on automated import of service metadata from AWS services such as AWS Cloud Formation Stacks, Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, and AWS Launch Wizard. Then view operations management data in the context of the application and perform change management tasks. Node management. AWS Systems Manager, Fleet Manager, streamlines the management process for servers running in the cloud or on-premise. Fleet Manager's remote management capabilities allow you to troubleshoot and configure your server fleet at scale, thereby saving you time and money. AWS Systems Manager, use cases. Centralize operations data, aggregate operational data, or ops data, and view it in a single console to gain actionable insights across AWS services such as Amazon CloudWatch, AWS CloudTrail, AWS Config, as well as third-party tools. Implement best practices. Automate proactive processes at scale such as patching and maintenance, or reactive processes to quickly diagnose and remediate operational issues before they affect users. Remediate security issues. Enhance your security and compliance profile, and analyze security incidents after the fact to prevent a future reoccurrence. Auto-resolve issues. Automatically resolve application issues by using ops data to easily manage applications and identify issues quickly across associated AWS resource groups.
Amazon Simple Storage Service Amazon S3. Access Management. By default, all Amazon S3 resources, such as buckets and objects, are private. Only the resource owner, an AWS account that created it, can access the resource. The resource owner can optionally grant access permissions to others by writing an access policy. Amazon S3 offers access policy options that can be broadly categorized as resource-based policies and user policies. Resource-based policies are access policies that you attach to your resources, such as buckets and objects. Bucket policies and access control lists, ACLs, are resource-based policies. You can also authenticate certain types of data access using query string authentication to grant temporary access to others with time-limited URLs. User policies are access policies that you attach to users. Access can be granted to users using AWS IAM policies. You may choose to use resource-based policies, user policies, or some combination of these to manage permissions to your Amazon S3 resources. Access Control List is a legacy access control mechanism. As a general rule, AWS recommends using S3 bucket policies, or IAM policies for access control. When Amazon S3 receives a request, it must evaluate all the access policies to determine whether to authorize or deny the request. First, let's look at resource-based policies. Access control lists. Each bucket and object have an access control list, an ACL, associated with it. Access control lists use Amazon S3 specific XML schema. It defines which AWS accounts or groups are granted access and the type of access they have. When you create a bucket or an object, Amazon S3 creates a default ACL that grants the resource owner full control over the resource. You can use access control lists to grant basic read-write permissions to other AWS accounts. Bucket policy, written in JSON, is attached to a S3 bucket. It provides access permissions to the S3 bucket and all objects in it. Here is an example of a S3 bucket policy. This S3 bucket policy allows the principal, the root account and the IAM user Alice under that account to perform any S3 operation. The wildcard * character after the S3 in the action statement, indicates that all S3 operations are allowed. Particularly, you can perform S3 operations only on specific resources, as shown in the resource statement. In this case, only the S3 bucket with name myBucket and all objects in it are allowed. As you can see, you can use the slash and asterisk after the bucket name to indicate all objects in the bucket. User policies control who has access to your Amazon S3 resources and is written in JSON. You can use AWS Identity and Access Management, AWS IAM, to create users, groups, and roles in your account and attach access policies to grant them access to Amazon S3. Let's look at an IAM policy example. Unlike bucket policies, IAM policy does not require a principal element, because the principal is by default the entity that the IAM policy is attached to. The first part of the policy specifies bucket level permissions. It allows the list bucket action so that applications can list all objects in the test bucket. The second part specifies object level permissions. It allows put object, get object, and delete object actions so that applications can write, read, and delete any objects in the test bucket. Amazon Virtual Private Cloud, VPC. Internet connectivity. An internet gateway is horizontally scaled, redundant, and highly available by default. It allows communication between your VPC and the internet. Internet gateway supports both IPv4 and IPv6 traffic. To enable internet access for instances in a VPC subnet, you must attach an internet gateway to your VPC, add a route to your subnet's route table, and point your route table to the internet gateway. Make sure your instances have public IPv4 address, IPv6 address, or elastic IP address. An elastic IP address is a static, public IPv4 address. Static means it does not change over time. You can rapidly move an elastic IP address from one instance or network interface to another. Lastly, ensure that your network access control lists, NACLs, and security groups allow the relevant traffic to flow to and from your instance. On the other hand, you need a NAT gateway in the public internet to enable instances in a private subnet to connect to the internet, but prevent the internet from initiating connections with the instances. NAT stands for Network Address Translation. When traffic goes to the internet, the source IPv4 address in the private subnet is translated to the NAT gateway's address at the public subnet. Similarly, for the response traffic, the NAT gateway translates the address back to the instance's private IPv4 address. To create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. You must also specify an elastic IP address to associate with the NAT gateway when you create it. After you've created a NAT gateway, you must update your route table for your private subnet to point internet traffic to the NAT gateway. Note that NAT gateway are not supported for IPv6 traffic. For IPv6 traffic, you would use an egress-only internet gateway instead. It allows outbound communication over IPv6 from instances in your VPC to the internet. At the same time, it also prevents resources on the internet from initiating communication with your instance directly. An egress-only internet gateway is stateful. It forwards traffic from the instances in the subnet to the internet, and then sends the response back to the instances. To route traffic from instances in your private subnet to the internet, you would need to add a route in the route table and point all internet-bound IPv6 traffic to an egress-only internet gateway.